All right, it's an exciting day here in Algebra 2 with Miss Treadway. We are looking at linear and quadratic systems. This is when I am looking for the intersection points between a parabola and a linear line. And most often this will happen in two places. So just like when we were solving our quadratic equations, we will get two solutions. So what we are going to be doing is making sure both equations are in y equals form. So for example, on this first one, I need to take this out of function notation. And then standard form, solving the quadratic equations for the x values and using that equation to find the y values. So once we've set them equal to each other, because that's going to be where they intersect, what I need to do is rearrange my equations so that everything is on one side, just like we did when we solved any other quadratic equation. So for this first one, I end up with negative x squared plus 3x plus 4 equals 0. Now this is one I want to factor, but I don't like it when my value in the front is negative, so I'm going to divide everything by -1 to change that, and I'll get x squared minus 3x minus 4 equals 0. So if I set up my x, -4 will go in the top, -3 will go in the bottom. Those two magic numbers that multiply to -4 and add to -3 are -4 and +1. A is 1, so I don't need to divide. So my two x values are going to be the opposite signs of this, right? I have 4 and -1. Now, all that tells me is the x coordinates of where those intersect. I still need to calculate the corresponding y values. So what I need to do is plug in this x and y into one of these equations. Well, the linear one, far less steps. So when x is equal to 4, y is -4 plus 2, which is -2. And when x is -1, y is minus -1 plus 2. That becomes positive, so that is 3. So my two intersection points for this first one are, this one is for -2, and the second one is -1, 3. So this one has kind of an extra step from what we have been doing previously, where we were looking for the x-intercepts. We are looking for an x-y pair here. All right, let's do the same thing on the next one. I'm going to set these equal to each other. I could take the time to rewrite them in y equals form, but we know what we're going to be doing next. Adding 2x, subtracting 7. So I get x squared minus 2x, that becomes 0, equals 0. So instead of doing my regular x method here, I'm just going to factor out the common factor of x, and that leaves me with x minus 2. So this tells me my two x values are going to be 0 and +2. Now to find the y's, I need to plug those into one of the equations. The linear one is much faster. So if x is 0, then y is -2 times 0 plus 7, which is 7. And if x is 2, then y is -2 times 2 plus 7. Well, -2 times 2 is -4. -4 plus 7 is 3. So my first point is 0, 7, and my second point is 2, 3. Okay, so that is solving algebraically by hand. We can also do this graphically. So if you're already given the two graphs, that is super nice and easy. You can just look for where they intersect. So here are my two equations. They're already on the graph. I have my parabola and my linear line. And I'm looking at the 2 points where they intersect, and this one here is at 2, 2, and this one over here is at 4, 6. So there are my two solutions. Now, if I don't already have them graphed and I need to do that by hand, that's fairly easy to do. I'm going to start with my linear one, and sorry, that y looks like it's cut off a little bit there. -x plus 5, that means that my intercept is at 5. And my slope is -1. So I'm just going to plot a bunch of points, connect the dots. Okay, now I need to graph my parabola. So I'm going to start by finding my vertex. H is going to be -b over 2a. That is 7 over 2. K is going to be, when I plug that in, 7 over 2 squared minus 7 times 7 over 2 plus 10, and that is negative 9/4. Okay, so I have a vertex at 7 halves, which is 3.5, and then negative 9/4, which is like 2 and change. So I'm just going to estimate where that vertex is. Another thing I can do is find my y-intercept. If these are both 0, that means my y-intercept is 10. Okay, that's helpful. So then I could find my symmetric point. I plot that axis of symmetry here. If it's 3.5 away on the left, I would have a point that is 3.5 away on the right. Okay. Now I can find my x-intercepts. This one I would be able to solve by factoring. This would be x minus 5 and x minus 2. So my two x-intercepts are 5 and 2. So looks like I already found one point where these two guys are going to cross paths. So if I'm connecting my dots, here's my parabola. Right here I've got a point where they are both, and that is at the point 5, 0. And then I'm going to connect my dots here, and it looks like I have found another point where they are crossing right here, and that is the point 1, 4. So there are my two intersection points, and you could check that in Desmos if you wanted to be super sure. And in fact, we are going to use Desmos for the last example here. I am going to graph both of those equations and look for where they cross. So the first one, y equals x squared plus 13x minus 5. And on the other one, y equals 3x minus 5. So I'm going to look for where those two are crossing, and it looks like I've got one point here at 0, negative 5. That's one intersection point. And then I might need to zoom out to find, here's the other one down here. And that is at the point negative 10, negative 35. So when in doubt, just graph. But there are my two solutions for that last problem. These are possible to solve by hand. If we could not have factored these, you could have used the quadratic formula instead. But factoring, graphing, algebraically, those are the ways we can solve a linear and quadratic system.